Okay, this is question 15 of the Madas MP1 series from madasmaths.com, and this is paper N. Use differentiation to establish the number of real solutions to this equation. So, this is a to the power 4 graph, so it's going to either look like a quadratic or it's going to look like a quadratic with two wiggles, and best case it's going to cross 1, 2, 3, 4 times. It might cross no times, it might cross 2 times, 1 times, 3 times. Yeah, it's going to look like that. And this plus 15 means that my initial sketch is it's going to cross the y-axis at positive 15. So that's a freebie. Okay, differentiating all this, you're going to get 12x cubed using the power rule. So you bring the power down and you then subtract a power. Minus 4x cubed will differentiate to minus 12x squared. Minus 12x squared will differentiate to minus 24x. And 15 will differentiate to 0. So this is, if all of this is y equals to this, you'll get that. Okay, so if I want to find the turning points, I set this equal to 0. I can clearly divide by 12 to get x brackets x squared minus x. Oopsie daisy, minus 2 equal to 0. X squared minus x minus 2, that seems to factorise quite nicely to x times by x minus 2 times by x plus 1. So that means it's going to have turning points x equals 0, x equals positive 2, and x equals negative 1. So when I sub in 0, I just get the 15 as expected. When I sub in 2, I'm going to have 2 to the 4, which is 16. 3 lots of that is 48. Minus 4 lots of 8, because that's 2 cubed, is going to be 24. No, stop it. 4 times 8 is 32. Minus 12 squared is minus 48. Plus the 15, so the 48's cancel. Minus 32 plus 15 is minus 17. So 2 minus 17 is going to be down here somewhere. So 2 minus 17 is that point here. And then when I substitute in minus 1, I'm going to have 3 lots of minus 1 to the 4, which is 3. Minus 4 lots of minus 1 cubed, so it's going to become a plus 4. Minus 12 lots of minus 1 squared, which is minus 12 lots of 1, which is minus 12, plus 15. Okay, so what have we got here? We've got 15 minus 12 is a 3. 3 plus 3 is 6, plus 4 is a 10, I believe. So minus 110 is going to be about here somewhere, minus 110. So if I was to attempt to draw a nice smooth curve, then here it's going to be a minimum, that's a maximum, comes down to a minimum, and then back up again, something like that. Oh, that's not drawn very well. That's a local maximum, this is a local minimum turning point, and this is a local minimum as well. So the amount of solutions I'm only interested in where it crosses the x-axis, there's just going to be 2 real solutions to this. Wicked.